exciting episode today. We're going to explore a talk that won both most educational and most inspiring at C++ Now. We have the speaker with us for this episode, and so we're going to be exploring that. First, though, I need to read our disclaimer, which is that this podcast and files transmitted with it are confidential and intended for the use of the individual or entity to whom they are addressed. If you have received this message in error, please notify the system manager. This message contains confidential information and is intended only for the individual named. If you are not the named addressee, you should not disseminate, distribute, or copy this message. So we're going to start out. I'm going to introduce our producer, Phil Nash, who's pulled together this really exciting topic, I think. Welcome, Phil.
Hello again. Yeah, I first came to hear about this at a meeting of C++ London a few months ago because Gashper, who's going to be on, comes to the meetup regularly, and he was quite excited about this idea that he'd been talking about. Was talking to me after the meeting, and he was trying to explain it to me, and the penny was starting to drop, but I hadn't quite got it by the end of the conversation. It was only a bit later that I really realized the implications of it. So I was really pleased to see Gashper give a talk on it at C++ Now a couple of weeks ago. So I thought it'd be a great idea to get him on, as well as Ben, who co-authored the paper, to talk about it a bit more.
Some of the videos of the talks are up yet, but this one's is not. So, and I think this actually happened a little late in the conference, so it'll be a while before that talk's up. But in the meantime, we will talk about it on this show. Actually, I think the genesis of this started with a talk that Ben gave quite a while back. So I'm going to ask Ben to start us off talking about what it was you were trying to accomplish and where all this came from.
Yeah, actually, it was a thing I was working on a few years ago. I was trying to write a futures library, and I was annoyed because I was using lambdas to carry values through the chain of futures, and I was sort of getting annoyed that at the point of call of a lambda, it was not possible to know whether the closure object was an L value or an R value, and so I couldn't move an object fully. I didn't know whether I could move. It was safe to move the object from the lambda, and so I couldn't achieve the ultimate performance that I wanted to achieve. So that was where the problem came from. Around, like I say, around 3 years ago, maybe 4 years ago now. So I'd had this problem on my mind for a few years, and then at Cpp.con last September in Bellevue, Gashper and I got to talking about it. And Gashper came up, and we were talking with Louis Dion as well at the time, and yeah, Gashper came up with this idea for solving the problem, and that's where the paper came from.
All right, you want to take it from there, Gashper?
Yeah. So I vividly remember this this part of the day. It was before the evening sessions, but after the main sessions of the day. We were all hungry, and the light was going, and it was all like super bleak before the lights turn on in the Maidenbauer. And everything was looking like doom and gloom, and Ben came up with this problem, and we're like, no, we need to get some dinner and talk about this. And then before we ever came out of the Maidenbauer, I was like, I know, let's just, call a spade. Like, we know that lambdas get this pointer. Let's just give it a name, and that'll solve like everything. And we started talking about it more over dinner, and well, now you can see the paper. because what came out was like, when we started thinking about it, it was like, oh wait, but we can do this with it, and that falls out. And then like maybe a few months later, we introduced it to Chandler at a committee meeting, and he's like, that solves curiously recurring template pattern. And we're like, it does? Oh yeah, it does. That's amazing. So yeah, that's sort of how it went. It kind of like started small and just, steamrolled from there.
So there's this, one of the things that I learned by using another language, which was Python in this case. Python has this philosophy that things should not be implicit, things should be explicit. And so Python doesn't have an implicit this pointer. They call it self, but it's just explicit. It's just another parameter. And it's kind of interesting that this little decision to make the this parameter implicit rather than explicit has kind of, there's a whole bunch of different things that your paper is hinting at. And even, we haven't even talked yet about the papers you haven't written that are based on this, but you've already been talking a little bit about it. This one change seems to affect all these different things. And it's all based on the fact that we've had this implicit this pointer and have tried to, we couldn't actually make a statement about what the this pointer is because it was implied and there was no way to reach it.
Yeah, we should probably say that this is P0847. And for those that want to look it up. And yeah, the Gashper and I started talking about it, and then it turned out that Simon Brand, who was on Cpp.chat last week, and Barry Revzin were independently working on basically the same idea. So we all joined forces for this paper.
Right. So how would you explain it in the fewest number of words, Gasper?
I can explain it in a long way. You didn't give me enough time to explain it shortly. But I guess if I had to, if you call this self, you can give it a name, you can give it a type, you can make it a template parameter, and that means it follows all the rules for parameters, and that's it. I mean, it's a really small change to the language that has really enormous consequences.
Right. The proposal is totally optional, and it's to simply, when you're writing a member function, the simplest way to put it is, if you're writing a member function, you can optionally call out the implicit this parameter as an explicit parameter with everything that implies.
As usual, Ben is way better at putting things shortly than I am.
And the fact is that there's a number of different situations where that makes a difference. We were talking about the lambda, but there's just a number of different situations where the being able to paint this parameter with whatever decoration we want allows us to express this is the function that we want to express.
Well, yes. I mean, the idea really is that if you can call something by a name, it definitely smells twice as good.
Well, to go back to the lambda example, I mean, in trying to figure out whether the lambda's closure object was R value or L value, I thought about, for member functions, we have reference qualifiers that can go on the end. So we have, a way to do this kind of for member functions already. But when you actually sort of exercise that right for member functions, you end up writing a lot of code copy-paste style, because you end up, say, writing getters, or a prime example, where you want to get a sub-object with the same value category as your this. You end up triplicating, quadruplicating in some cases the getter function. And it would be easier to write it once and to just deduce the type of this.
It's kind of difficult to talk about this paper without, showing the syntax that gets just massively shorter. But, like, I'm sure that you've had to write at least the const and non-const versions of methods all the time. And with C++11, we got our values, and that means that really most of the time you should be writing 4 overloads, the ref1 and the const ref1, even though people don't even know about the const ref1. And so you actually would get all this for free if we had this.
So how do we get this for free? What is different? What do I do as a user once this is involved? This paper passes. Now what do I do? How's my life changed?
All right. So let's say you're writing any kind of data structure that offers access to members, which every data structure realistically should, since it's a data structure. All of your accessors only need one template overload and not, 4 non-templates.
So if I'm writing vector, then I need to be able to write both the const and the non-const accessors to members, or to not members, but to elements.
And the ref and the const ref, and that same goes for front, for back, and for at.
And for data.
And for data. No, data is a little different. I honestly don't think you should be handing out data when you don't have an L value. Like, that would be really weird.
But yeah, there are lots of accessors in many containers that fit this pattern. And in regular structs too, that you might write it just in non-library code.
Yeah, so, not many people know this, but you get all of this for free when you write a struct with no accessors, right? All of the member accessors get all of these qualifiers for free.
So to answer John's question concretely, instead of writing, some getter with a const ref version, a ref version, and the other and a L value mutable ref version, etc. What you do is write the getter once and give it a explicit parameter which you name, and you mark with the keyword this, which is the first parameter of the getter.
Right, and then that is a template.
Well, you write template type name T, my getter, this T ref self, or any other identifier, and then all the other parameters if you have any. And then you can stud forward on T, right? Because you have it, and you have self, and you can decal type on self, and you know exactly which value category you are.
Yeah, the function you write looks exactly like it's a template. It's a function template with a forwarding reference, basically a deduced reference.
So what other? Okay, so that's nice. Saves me some boilerplate. What other things can we do with this? One of the things that we were talking about, we had a user group meeting last night, and Arthur was talking about how it changes CRTP into just CRP.
It's not even a recurring pattern anymore. It's just, yeah, write this.
Okay, so explain this.
All right, so the way it works, right, if you think about normal template parameters, forget this weird one that we're introducing. When you have a template and you have, type A that inherits from B, B being base and A is your, fancy derived type. If you call foo, which is a template, on A, you're going to get foo that's templated on A, and if you call foo of B, you're going to get foo that's templated on B. These are two different functions, right? So basically, in normal functions, this gets deduced to the statically derived type of whatever you're calling it on. Same goes for deduce this. So if you have a method on the base class and you call it from the derived class, the template rules as they're written now make that deduce to the statically derived type of whatever you're calling it on, which is, A in this case. So that basically allows the method to get the statically derived type, like the most derived type, inside the body by just looking at what the template parameter deduced to. And so you don't need CRTP to tell you that. And not even that, like you don't need weird static casts that you have to explain to everybody anymore, because self is of the correct type. It's a reference to A, and not to the base class. However, because we also didn't want to change what the this pointer points to, because that would be weird also. Like, we didn't want to write any new rules effectively. This still is a pointer and points to the base class, because this is a method of the base class. So if you want the base class's members, just write this, or don't write anything, because if you don't write anything and you just use the name, it'll be, you know, implicitly looked up through this. If, however, the derived class has a member of the same name that shadows the one in the base class, you can just say self.thatMember and you'll get it. So you have access to both, and it just magically works by today's rules.
Right. We're assuming that. So when Gaspar says self.member, conventionally we've been calling the implicit this pointer self. That's just the name we've been giving to it. It doesn't have to be self, but that's a conventional name.
But it can't be this, because that's a keyword.
That's a keyword, yeah.
Yeah. So you do have to, when you're declaring your this object, your this pointer, you have to give it a name other than this. This is still in the syntax to simply tell the compiler, by the way, the object that I'm naming here is the this pointer that that we would have in this situation.
I mean, technically, you don't have to give it a name if you just care about the type, because we all know that you can omit the identifier from a parameter, right? So technically, you don't have to call it anything. I don't know why you would do that, but
well, you get the right.
The lambda case is a case where you might want the, I think, where you might want the type, but not necessarily want to name it. I'm not sure.
Yeah, but you can't get it, right? In the lambda, you don't have the luxury of naming that type. Oh no, wait, we do now. We have like explicit template lambdas, right? You can actually name that thing now.
What do you mean now? Are you saying with your proposal, or are you saying
no?
Like
Like
have that in 17?
I mean, obviously.
Is that accepted in?
What?
Is that accepted in?
Is anything?
Well, that's what I was wondering. So we don't necessarily have it.
It was in Mateusz's talk that was just in Aspen, that is recently up on YouTube now. He gave a talk C++17 or beyond C++17, where he did mention that paper. So I believe now you got me wondering whether it's in, because he covered some things that were in and some things that weren't quite, but I think it's favorable.
Yeah, I mean, there's no reason to really omit it, right?
All right, what other uses do we have for it? We should say that the plan is that you have a paper that that is being submitted now for Apperswell, but you've got 4 other papers that you plan to write that aren't written yet, that are based on building on this this proposal. Is that right?
Yeah. Though I think that we should stop on one other use that we already proposed with this proposal before we go on to further papers.
Okay.
And that's that this solves recursive lambdas. Because currently a lambda can't call itself unless you go through stud function or some other trick like that. But because in this case, you would get like this auto self as the first parameter to a lambda, you have a way to name the lambda from inside the lambda. It's called self. So you can call yourself, and suddenly you have recursive lambdas. And that's not just good for recursion. That's also good for, let's say, you register the lambda as a callback, and well, you get called. And then you figure out that whatever you were being called for hasn't actually happened yet, and you were called spuriously, and you need to re-register yourself as the callback. Now you can do that. And you can just literally move yourself back into the framework. You don't even have to copy the lambda, right? Because you know that you're never going to be called anymore, perhaps.
Right. So you can write these kind of asynchronous kind of tail recursive function chains where the lambda just says, call me back next time. This, by the way, is also a thing that solves my original problem, the ability to do decal type of self from inside the Lambda body and figure out what the value category of the closure object is.
Which was the solution, which is what you were trying to solve initially.
Right.
Exactly.
Now, lambdas are a little bit odd in the standard in that, so there are very restricted things you're allowed to do. Given that you have a name for the closure object, you can't do what you would naively think you could do with a this pointer, which is to access members of the closure object with that syntax at least, because or take the address of them or anything like that, because the standard doesn't give the closure object any kind of defined layout. So there are restrictions on what you can do with that inside a Lambda that are slightly different from member functions. But basically it does exactly what you would think it would do in the cases that you're allowed to do things.
It looks like Barry, one of your co-authors, is in the chat room.
Yeah, I'm sorry. People have intelligent questions. For instance, Defray says whether the shorter syntax was considered, and I gotta answer that it's actually not the syntax that he's proposing. You can. Oh yeah, that's for methods. I actually don't think that. Okay, so let me summarize what he's saying. He's saying that instead of writing this weird new thing that we're proposing, to write just autofoo this ref, and have the method instead of writing template blah 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 autofoo. And I have to say that we have considered this syntax. It doesn't give you half the things that we want, and also it's a special case as opposed to just fitting in with the rest of the system. Like, it's a surprising syntax. Also, it doesn't quite communicate that what you wrote is a template, and that's a big no-no for some parts of the committee. That's my entire answer.
Yeah.
What about these things, I forget what they're calling them now, where you combine a load of lambdas together as an overload set using inheritance? Would you be able to call from one overload to another?
I like that one. So with the proposed stud overload, wait, is it in 17 or is it that at 20?
Stud overload, that's it.
Yeah. So with stud overload, you can already combine a bunch of lambdas and functions into an overload set. That's not the new bit, right? The new bit is that when you combine this with lambdas effectively having a way to refer to themselves with this auto self parameters.
Okay, hang on a second. Step back a second. How do you do that? How do I make several lambdas an overload set?
Okay, so you write auto my overload set equals stud overload open paren. It's a function, right? And then you just list all your lambdas and then close parens and semicolon. And what that does is it creates an overload object that just inherits from all of the lambdas that you gave it. It's a type you can't really name, which is why you had to specify auto my overload set equals in the beginning. But because a Voldemort's type. Yeah.
Yes.
So.
Right.
So yeah, once you have that,
you
can call it with any one of the call operators that it's inherited from, right? So that's why you've effectively packaged up an overload set into an anonymous object.
And that's some new thing? Is that 17 or is that?
I think it's 20.
I think right, because 17 introduced variadic using, which gives the ability to bring all of the operator paren methods into the derived object with a very simple syntax. So I think that was the thing that really unlocked. So I know Vittorio Romeo did a talk on this, and it can be done in C++ 14. In 17, it gets a lot easier to implement because of the variadic using in particular.
Okay, so I just interrupted you about this now. Okay, now we understand how you do just a standard overload set of lambdas. Now, what is it that we're going to do with that?
You want to take this one, Ben?
Let's see. Why don't you? It was your story.
All right. So I guess I'll take that one. So the way it works is when a lambda knows how to refer to its own object by this auto self as the first parameter, if you think about it, stud overload inherits from all of these things, right? So when you call the stud overload, what does self refer to? Well, it refers to the most derived type, right? Which is stud overload. So that means you can not only recursively call yourself, you can recursively call the stud overload, which is any one of the lambdas that are in your overload set, effectively. So now you've got self-recursive overload sets, which for certain types of things are very, very useful. And the certain types of things, I mean, using them, for instance, with stud visit on recursively defined variants, which is how you make trees, right? So if you wanted to visit every part of the tree, you need to recursively call yourself, but with the node type that is, you know, dynamically determined by stud visit. So you need to really like pass self, as in the full overload set, back to stud visit to recursively call yourself, and you can do that without using stud function tricks like you have to today, which is way faster, right?
Right. So you have one lambda that deals with the case where you're a branch, one lambda that deals with the case where you're a leaf. You package them up in an
one
overload.
of the several types of branches that you have.
Sure. But let's a simple example would be one lambda that deals with the branch, one lambda that deals with the leaf. Each of those lambdas can reference the templated this or self object, and that is the whole overload set. So the lambdas get to sort of know how to call each other through calling the top level overload.
Or Michael's suggesting you could just give it a named type.
Yeah, I was going to say this all sounds very futuristic, but we've been able to do this since C++ 03 or earlier, just by writing your own class with an overloaded parentheses operator.
That is true.
Well, it's fun.
Now you're spoiling all the fun.
Well, the thing is, okay, no. So that's not actually true, because sometimes you want to do that with the local state of a function, and that means you gotta write lambdas. You can't write named types inside functions yet. I mean, at least not ones that would be useful. You can sort of, kind of. It's weird.
So the other question that I had, winding right back, you said at the beginning that you get all this for free with your proposal, but there is a cost in that now you've got to make a lot of things that maybe previously didn't have to be templates and didn't have to be visible in a header file, for example, into templates, just to be able to take advantage of the different deductions. So there is a cost in terms of often compile times.
Yeah, that I would say that there's a cost to misusing lots of things in C++. But back to the one of the original use cases is writing getters, right? And right now they are typically inlined in headers because you want them inlined. and you want to give the compiler that hint. So it's using the compiler through a template mechanism to write the functions, and you don't have to write them.
I'm going to say modules is going to solve that.
Modules will solve everything. That's why it's taking so long.
Well, they got to front load all that compile time.
Maybe. Yeah, but I think your point, Ben, is that actually most of the time it won't matter because they were already going to be inlined anyway.
I think a lot of the use cases will improve, will reduce the amount of code you have to write, and actually won't make a difference to header size. Yes, I mean, to your point, we can always put everything in headers and abuse the compile times.
My favorite bit about making them templates is actually that we have a widget to make all those getters correct, and it's called stood forward, right? And if, like right now, I have to manually inspect all of the return types, all of the annotations, and convince myself that it's actually correct, because testing that is also really error prone, because if you've copy pasted the methods, you're also going to copy paste the test. And making sure that all of those things are modified by hand exactly correctly and that stays the way it's supposed to is kind of difficult. And here we've got an automated widget that everybody already knows how to use that just magically make your getters correct.
Right. That's my vote.
Did you actually, Gaspar, did you want to mention forward like along those lines?
Oh yeah, that's a bit of a paper that is not in this paper because proposing language features and library features together does not seem to be a good idea. Because of this difference of deducing to the statically derived type instead of, you know, the base class, you actually need a slightly different forward, which we call forward like, that copies the qualifiers but not the type. You can use stood forward, and in that case, it will always be correct, but it might fail to compile in cases where you weren't thinking ahead. So basically, you're safe. You just might get a lot more for free if you use forward like. There's also another extension that was proposed by Alasdair Meredith that marking this parameter as explicit would always deduce to the type that's the base class, so that would be less surprising. It does break the current template deduction rules, which is why it's, you know, a separate keyword and stuff like that. We still need to think about that a lot more, but in that case, straightforward would just always work.
One of the things we tried to do with this paper was actually change as little as possible, ideally nothing, about the way the language deals with templates, deduction, all that stuff. So this paper, in a sense, is just a very targeted syntactic change that's opt-in. And we don't want to really mess with the way that all those deduction and lookup rules work, because people know those, and ideally everything would work the way people would expect, except just if you add this thing, here's what you can here's what you would expect.
Well, thank you very much for not complicating those rules, because right,
and that extends to things like if you write one of these and you write effectively, if you write the template and then you write the same function that the template would produce, what does that mean? Well, it probably means that you've written the same function twice, and the compiler should tell you, I've got a duplicate of that function, and that's just a link error or whatever it might be. Is that right, Gaspar? Is that where we landed?
Sorry, you're going to have to repeat that because I was reading the chat.
What was the answer to the question of if you let's say you write a getter template in this style of the paper, and then you write another old style explicit getter explicitly value qualified.
Oh no, that's not a linker error. I mean, in the worst case, it's a linker error because you've written those in two compilation units, but you can't actually do that because you're writing these as a method of a class. So the current
compiler should know you've done it.
Yeah, no. I mean, the current way the compiler deals with this is it tells you you've declared the same method twice, and it refuses to compile, not link.
Right.
I mean, it is literally the same thing. Like, you can copy and paste the method right now and see what the compiler says. And it'll tell you, you've already defined this. Stop doing things. Go home, you're drunk.
Right, right. So that's another example of where we're not trying to change anything. Just whatever the compiler does now, the way it interprets these things now is the way we intend this paper to interpret things.
Except that, maybe I'm misunderstanding exactly what you're saying, but if you were to write, let's say I write the copy constructor for a type, but that I also write a template constructor that could take anything, that is essentially writing the copy constructor again, but because it's a template, the compiler is not going to detect that. It's just going to pick the real copy constructor over the template copy constructor.
Yes.
And so it's not going to detect that that's actually a redeclaration, because it's not.
Again, the behavior is exactly the same as now. Although we don't actually allow you to have constructors with an explicit this, because it makes very, very little sense.
The special member functions, yeah, I don't think we want to mess with those.
Instead of saying constructor, it could have been the copy assignment or something like that. I mean, it's the same. The principle is the same, which is that the compiler doesn't see a template and a non-template as the declaration of the same thing, even though they could be used the same thing, because it's just going to prefer the non-template version when it actually writes.
Yes, John. In accordance with your previous statement of not complicating things, we definitely didn't want to overcomplicate function lookup rules.
That's right. That's exactly that. Yeah, because those are already complicated enough.
Yes, this paper changes nothing.
All right. Well, let's talk about some of the other papers then. The future papers to be written. What is it you want to accomplish in your once you've got this nose in the door with this proposal?
Right. So let me preface this with, if we don't get any of the subsequent papers, I will totally be happy. I just don't want to repeat myself. However, even in the talk that I gave at C++ Now about this, people were already jumping 40 slides ahead in anticipation of this. So it's kind of obvious where this leads. So we obviously also thought about where this leads, and I mean, if you're writing a paper, you should probably explore where it leads like 2 or 3 steps ahead. Otherwise, you haven't done your homework, right? So we did that, and let me start with I guess the most useful one, or like the obvious one, which is by value parameters. Like, we can pass most things by value in C++. Why not self? It turns out that that's a really interesting proposition. It solves a bunch of problems where you can't pass an overload set, but you still want value semantics or methods. It solves effectively the builder pattern for it to be type safe. Because instead of basically constructing on assignment, you can construct every time and just move construct yourself into the parameter. And if you drop your type on the floor because of an exception, it's all fine. And you're type safe all the way. Because
you just made a copy.
Well, or you moved, because basically when you have a builder pattern, right, you're chaining with ... and all of these things are returned by value, which means there are values, which means they move construct into the parameter of the next dot call and so on. So the compiler is very free to optimize those away because it knows you've never taken the address of them and so on. Like, and with today's, I mean, I'm not entirely sure if you could write some rules for this to effectively be RVO'd because you currently can't RVO parameters, but in this case it's kind of special, so you might be able to. Because you know you're tail recursing, right? So you could just operate.
Works on parameters, sure.
Copy elision, I'm not sure if it works on parameters because you need to construct into the return slot on the stack.
Oh, you're trying to do both copy elision and RVO.
Construct into the parameter, yeah. And I think you could actually do that because you're basically continuation passing, and the compiler could detect that and do things, but probably not in the general case. Not in the general case.
Absolutely, you're going to need to inline it. Otherwise, the compiler can't see it. If it's inline, though, well, compiler can pretty much do what it wants then, because it understands all the side effects and knows there aren't any.
Yeah, exactly. So that would be really cool. And because they're not templates, right? You can type erase them, which means you can have type erase builder patterns. Yeah.
All right. So what's next? Because that, I have to admit that what's next is more interesting to me than the by value parameters. I don't get excited about the by value parameters, but I thought the next thing was very interesting.
Yeah. Okay. So the next thing I like to call friendship is magic. Let's say you had this annotated method and you marked it friend. What would that do? Well, clearly it would export it into the enclosing namespace to be able to be called as a free function, because obviously that's what friend does. But it's also a method with an explicitly annotated this parameter. So why not be able to call it as a method? And effectively that gives us opt-in uniform function call syntax for that one function, which solves most of the problems that people had with the previous uniform function call syntax papers. Because this is totally opt-in, it doesn't break anyone's code because there's no code like this out there. It allows you to selectively control your namespace, but on the other hand, it's really just a way to say this function can be called two ways. And it's a method, so you can't just arbitrarily add them. All your namespace control is perfect. It's kind of like the first obvious extension of this. Now, of course, you could also go the other way, which I call the, oh, hi, I'm your method approach, which is you have a free function, you annotate the first parameter with this, and magically it can be called with the method syntax. And obviously it's not a friend, so it doesn't have access to any of the private state and so on. But all you've done is you've just adapted a thing that can now support the method syntax. And I mean, personally, I'm a little less excited about that one because it allows you to hijack template methods of a class and inject like things into the lookup table, and people that were already trying to resort to methods as a way to solve argument-dependent lookup problems get their, cookie taken away from them. So I'm not too hopeful of this getting through the committee.
So in other words, the committee is probably more likely to buy off onto uniform call syntax if what they're seeing is a member that is simply able to be called as if it was a free function, rather than to allow people to write free functions but then call them as members.
I would expect so, because namespace control is already a pain point, and making it worse is not the way to go. And also, you know, friendship is magic, but somebody just coming into your house and saying, "I'm yours," is only welcome in certain circumstances.
Right. So we do have, with this proposal, we do have uniform call syntax, but it is strictly under the control of the author of the type. And it's up to the author of the type to decide which functions can be called either way.
Exactly. And let me reiterate, this is not the proposal that has a paper already. This is a separate paper. But
right.
Yes, this is the proposal we're currently discussing.
Right.
It does get confusing when we talk about this proposal, when we're talking about this proposal.
It inherits. Yeah.
All right. Other things in future papers that we should be on the lookout for?
Yeah. So there's also a thing that people predicted, which is, what about annotating, not the first parameter? And honestly, I really like that, especially and honestly only for things that can be called both ways, because annotating not the first parameter for a method that can only be called with method syntax just doesn't make sense.
I don't understand it.
All right, so okay, Ben, please. Sorry.
I was going to lead off with a good example, which is the find example. So in a free function, syntax, you would naturally write find needle, haystack, let's say, right? That would be a natural way. But it's the haystack, which is the data structure, and it's the haystack that knows how to do the well-performing find. So the find operation is in some sense defined on the haystack, but you want to call it naturally in the free function sense by saying find needle, haystack.
Yes.
That's all I had to say.
No, that kind of makes sense. What I didn't understand is how you would call it as a member. That's what Gasper was saying, is it
right.
It seemed to make sense. And I was just saying, no, I don't understand how it would make sense at all. That confused me totally if it's a member.
Right. So if you define such a find method on a container, you would still call it haystack.find of needle. Right?
Right.
And so it's only when you call it through the free function syntax that the fact that the second parameter is the annotated one comes into effect. When you call it as a method, you omit the annotated parameter.
Regardless of where it falls in the list.
Regardless of where it falls, yes. And so if you're not using uniform function call syntax, annotating anything but the first parameter just doesn't make sense, because it's the same syntax to call it regardless.
Okay, I can understand that.
Yeah, sorry. I guess my wording was not, perfect. Your objection was correct. Right. And I think that's about it for the obvious extensions of this paper.
So let's talk about as you presented it. It generated a lot of excitement in the room, and I'm looking forward to seeing people see the video. One of the things that we get at C++ Now is sometimes criticisms about either the videos or even people who are experiencing it for the first time, because there's so many interruptions going on. Let the speakers speak. And I think people don't appreciate that that's really what this conference is about. It's the discussion in the room. And so I kind of wonder how people are going to respond when they see this video where, I don't know what it was, 10 minutes into the talk where Gasper says, okay, that's the proposal, we can go now. And instead, there's just all this discussion that happened for the next 80 minutes or whatever it was. So there was a lot of discussion. Did you expect that? Were you ready for that?
Yeah. I mean, I felt like a puppeteer after it because that's exactly what I was going for. I did tell the audience as much at the very beginning, right? I mean, it was a session that was specifically geared towards C++ now, and I personally made sure that all of the people that I thought I needed to generate the discussion were in the room. Yeah, that was a fair bit of diplomacy in the days preceding, and I was really happy that Ellis Dare decided to come because he wasn't about to, and I told him, well, I asked him very nicely to come the previous session, and he said, well, you know, I was gonna go to Michael's session, but if you really want me there, so sorry, Michael. And
Well,
yeah, sorry.
I was just going to say, I knew that you'd approached me, and I heard you approaching people, and so I was really worried that it was going to be standing room, and so when Phil said, "I'm going to this talk," I said, "Oh, well, I got to do this. I got to deal with something. So save me a seat," because I assumed that was the only way I was going to get to sit down. And I got there, and it wasn't completely full. I was like, do people not realize that this is going to be the fun talk? And apparently they didn't. And the other thing I thought, well, he can't win best session because he doesn't have enough people here to vote for it. There's not going to be enough people. But obviously, everybody who was there voted with all their votes on this one session, right? because I guess you didn't win. Ben won best session, right?
Yeah, Ben won best session.
Well, and I was going to say that Michael won. What was the
most engaging with?
Well, Michael's talk was opposite Gashper's, and both of those talks ended up being voted highly.
Yeah,
I don't remember which or what it was that Michael.
I think I got most engaging, and Michael got most educational.
Yes,
no, I think it was the other way around. I'm pretty sure.
It was the other way around.
There was most engaging and most inspiring was Gashper, and I think most educational was Michael.
No, Michael was most engaging, and Gasper was most inspiring and most educational.
Yeah. I was a little.
I guess I got my words messed up. All right. Yeah. Well, anyway, yeah, it was supposed to be a really, really interactive session, and that's why in the beginning I was like, I only have 46 slides. That's 1 a minute. That's really not, you know. And then I spoke with Louis, and he said, you know what you should do? You should do bonus slides. In the end, I only skimmed very, very quickly through the bonus slides.
Yeah, Michael's in the chat room, and he said, friendship is magic. So.
Yeah, it is. And I was actually really sad that Michael and I conflicted, because I really wanted to go to his session, but unfortunately I really had to go to mine.
Yeah. Yeah, it would have been a different session if you hadn't been there.
I was also, I wanted to go to Michael's talk, but I felt that I should, you know, as a co-author and supporter of Gasper, I should go to his talk. But it was a tough choice.
I guess we need to figure out who does the scheduling and blame them. Oh wait. Oh no, let's not do that. That's the one thing we don't
blame Bryce. It's okay.
Right. Well,
that's right. Bryce does the scheduling. Sure. Yeah.
The one thing I called out as a scheduling requirement for myself was that my talk was not scheduled opposite Gashper's.
Yes, that's right. I remember that now. Yes. Yeah.
No. Right. Well, before we go on, I really want to plug another paper of mine that I just wrote. It just got a paper number yesterday, and it's the shortest paper you've probably ever read, and it's called Using Enum. And you should be able to say using enum, my enum, where my enum is a class enum, and import your identifiers into the local scope. And that's literally the paper.
And Michael wants to know when you're going to implement this in Clang.
As soon as I get the time. It is very, very difficult to get time. And also, I think I need a new computer to do that, because Clang is a lot of source code, and recompiling it on my poor 2012 MacBook Pro is just not working. Because apparently to compile Clang you need more than 8 gigs of RAM, and I just don't have it. So yeah.
Isn't that what AWS and Azure are for?
Yeah, I guess I could, you know, make a dev box on AWS. That's gonna
Won't be long,
fun.
you'll be able to compile it in Godbolt.
There you go.
Yeah.
There you go. All right. So explain to us what the point of this is now. You want to be able to pull enums into the current scope by just saying using enum.
Yeah, I wanna be able to say, if I have a class enum, instead of writing my class foo, my class bar, my class baz in every one of the, you know, case statements of a switch. I mean, let's do less abstract. Let's do colors, right? So we all know blue's a color. Unfortunately, we don't want blue polluting our normal namespace, so we make class enums, and we want the nice type safety that they bring. But when you're switching on color, you don't want to be writing color : blue, color : red, color : yellow all the time. So you just, you know, using enum color in your local scope and make a switch on the actual identifiers. Like, why not?
Sure.
Enums are just namespaces for values. Let's, you know, use them that way.
Treat them like namespaces. Okay. All right.
Yeah, I have to admit, I often fall back to the older enums for exactly that reason. They just clutter up the code a lot more. But I do want the type safety of modern enums.
I misunderstood. Michael was saying he wasn't talking about the enum proposal, the implementation. He was talking about this proposal.
Yeah, I was answering about this proposal.
Okay.
I think using enum is actually far easier to implement than the this proposal, but the this proposal, as far as I was looking at it, isn't that difficult either. There's not too many places where you need to change the code, because most of the bits are in just making the parser stomach the keyword over there. And then it's a little bit about binding in some other place. And, you know, maybe I'm missing a few places because I'm not a Clang expert.
Well, you're definitely trying to leverage all the existing rules. You're not trying to change any rules, right? So that is
exactly,
that's what makes it shouldn't be that. But it would be.
I remembered I wanted to ask the most important question. If I'm reading it right, you can put the this keyword to the left or the right of the type. So we're going to have east this and west this.
You can't.
Okay.
You can't put it on either side because it is not an identifier. You can't put it after the type. And we've bike shed that syntax.
Right.
And it turned out that the British Standards Institute did not like it. And for a good reason. It's because when you wrote T this self, it looked like, and when you omitted the self, it looked like this was the identifier that T referred to, and that would confuse the hell out of people, because this would still be a pointer and not a reference in those cases.
Yeah.
So it was decided that this can only be before the type. And also, when I was talking to Timur Damler, who is in charge of implementing the lexers for Sea Lion, to plug our video sponsor.
Not actually a
He
sponsor.
said this is.
Not actually
Video
a sponsor
sponsor for
here.
the conference. He
For
said.
the conference,
There's
yeah.
the sponsor for the conference, yeah. The PhD says West this. Yeah. So yeah, he said that this is terrifically easy to implement in their lecture, so that's really great for tooling as well.
Yeah, yeah.
Just
All
a
right.
final thing on West this. The reason I brought it up is because the R0 of the paper has East this, R1 has West this. So that changed between the two revisions, did it?
Yes, and that's because we showed it to the British Standards Institute, and well, these be the results.
Okay.
There was an official poll and everything.
All right. So we need to wind down. I try to keep these not too much longer than an hour, so we do need to wind down. I think we have kind of one announcement, which is that we're now in the middle of conference season. So if you're having an itch to speak, there's a call for speakers open currently for Meeting C++. There's a call for speakers currently open for Pacific++. And for C++ on the C, I don't think the call is out yet, but you're actually encouraging people to get on the mailing list so that you can contact them when the call goes out. Is that right, Phil?
That's right. I'm actually going to aim to open the call for papers tomorrow. If I don't get to that, it's going to be a couple of weeks because I'm going to be traveling after that. So hopefully that will go out tomorrow. Otherwise, you can register on that link.
Okay. I need to actually send an email to all of the C++ Now speakers and encourage them to do those kinds of things because I need to encourage them to get their slides in. There's an awful lot of slides that are up online, but I don't think all the slides are there yet. And there's a few other things that I want to encourage speakers to do, so that email still has to go out. But anyway, I want to thank you guys for joining and telling us a little bit about this proposal. Anything else that we need to cover before we say goodbye?
No, this was awesome. Thanks.
Did you have something you wanted to promote, Ben?
No, nothing else from me. It's a good chat.
All right. Okay. Well, then I guess we'll wind it up and say to everyone, safe computing.
Safe computing.
Safe coding. Safe coding.
Safe coding indeed.
Okay. Thank you guys very much.